Okay, hello everyone. Today we are going to introduce how we improved the predictions on loan default. And so first of all, I'm gonna talk about how we improved the performance of our classifier. First of all, we performed feature engineering in which we applied several feature engineering techniques such as interaction features. So we created features such as loan amount to income ratio and interest rate to credit scores to better capture financial health. We also added polynomial features, which are nonlinear relationships through polynomial features that can capture complex patterns. Additionally, we encoded using a cat-boost encoder for categorical variables. These enhancements help the model understand applicant financial stability and risk more effectively. So our model comparison, we tested three models. The first one is Light GBM, which has high efficiency, fast training, and excellent performance with large data sets. We also did XGBoost, which is known for robust performance and effective handling of missing values. Additionally, we tried Random Forest, which provided a good baseline but underperformed compared to the boosting models. In terms of F1 score, we have the light GBM score is 0.65, the XG boost is 0.67, Random Forest F1 score is 0.61. So we concluded that XG boost achieved the highest F1 score, making it a valuable classifier for us. And it is worthy to note that we also handled data imbalance because as we can see here, the data is very imbalanced between default and not default. And to address this imbalance, we used SMOTE, which synthetically generates minority class samples. This balanced the data set, preventing the model from biasing towards the majority class. Um, and another step that we took was hyperparameter tuning. We used hyperparameter tuning to explore parameters like learning rate, number of leaves, and maximum depths. Before tuning, our best F1 score was around 0.62. After tuning, we improved it to 0.67, demonstrating the significant impact of parameter optimization. Um, to assess and improve the fit of our classifier, we used the validation strategy. We used k-fold cross validation, which ensured that performance stability and uh, reduced variance between training and validation scores. We also compared to a simple training test split, k-fold provided a more reliable performance estimates. Um, another step that we took was learning curve analysis. Um, so we plotted a learning curve to assess the underfitting and overfitting. Uh, Initially, there was a large gap. Um, Initially, there was a large gap between training and validation scores, indicating overfitting. By applying regularization and adjusting tree depths, we narrowed this gap. Um, we also used confusion matrix to review that while our false positives decreased after tuning, some false negatives persisted, and the precision recall curve emphasized the importance of balancing loan approvals while minimizing defaults. In a business context, false negatives are more costly than false positives.
So about problem 3, first we would integrate external data sets such like macroeconomic indicators, unemployment rates, and the inflection trends affecting repayment probabilities. So second is credit data, more detailed credit histories to define the credit worthiness assessments. So secondly, to production employment, we would implement for data drift detection. So the regular monitoring to identify changes in data patterns over time. And the performance tracking, we automatic alerts if one score declined below their host. So this practice through the feature engineer modeling selection and the validation strategies, we significantly improve our classifier for F1 score. So with more resources integrating external data and the robust monitoring would further enhance predictive and reliable. So thank you. Stop recording.